So now we have the water level up about here in our flush cart, again below our T return. We're going to go ahead and open up the valve down here and turn the pump on. Going to add a little bit more water. Adding water again to keep that water level as best we can just above that return T. And that's pretty good on the water. Dislodging more air, you'll actually see the video, the flush cart kind of shake a little bit. That's the air coming back out of your loop. I'm going to go ahead and put a little bit more water back in. Here's some air coming back. That's good on the water. Again, we're still getting some air returning from the loop, so the pump's doing what it is designed to do, which is achieve that minimum 2 feet per second velocity, so again we can dislodge the air. If you do not get all the air out of a pressurized closed loop system, it will simulate a leak forever. Ground loops rarely have leaks if they've been installed properly, all your welds have been properly performed. However, there's a number of loops out there I've heard of that have been condemned when in fact they didn't leak, they just were improperly purged. Remember, your gases or your air pockets will compress, liquids do not. So now that I'm not seeing any air returning back from our loop, I'm pretty confident we have all the air out. I've actually gone through a deadheading process and looking for how much compression level drop there is in our fluid. Again, please reference that on our flushing video in great detail. This is in particular just on flushing the plug and play, not specifically the loop. So again, those details are going to be on our flushing video. So now it's time to go ahead and orient our flushing valves, internal flushing valves, so that we now can flush through the coaxial heat exchanger. Now we're directing all that flow through the coaxial heat exchanger internally. Again, make sure we've dislodged all the air out of that. Please don't skip that step. It'll cause you a lot of difficulty. So we're going to keep an eye on that. We'll go through again a couple of deadheading procedures to make sure we've successfully removed all that air. Now that we're pretty certain we've got all the air removed out of the coaxial heat exchanger by again starting to do some deadheading and compression tests, now we're ready to deadhead the pump and apply some pressure. It's important while you're doing this to make sure that you have the expansion tank valve handle in the closed position, because if you leave it open, if you skip that step, what will occur is you will compress the bladder that's in that expansion tank, and it'll simulate as if you have an air pocket, which essentially you kind of do. By closing that valve, that eliminates that from occurring and makes you more confident you in fact have removed that air out. So now the very next important step is to bleed the air out of that expansion tank line. Again, we got the pump running. We're under, in this case, about 35 pounds of pressure. We're going to take a rag. We're going to depress the valve stem and get all the air out of the Small pipe going out to the expansion tank. Do that until we get nothing but water out of the system. There we go. Make sure we put that cap back on. Okay. Now we're ready to rotate those internal flush valves so that we are circulating through both the coaxial heat exchanger and the loop at the same time. We'll want to let that circulate for a little while. All right, we've performed several deadheadings. We're confident we've got all the air removed. Again, this would be that point in time. If you're introducing antifreeze, you rotate those flushing valves inside the machine and introduce your antifreeze. And always, if you're adding antifreeze, you do the antifreeze level check. Make sure you have the concentration and freeze protection level that you need. We're getting ready to go ahead and pressurize the system again. This is a video that's covering a pressurization loop. We're going to have some others down the path here about some non-pressurized. But one of the steps you don't want to miss, guys, is we now have an expansion tank in here. You want to make sure you open up that valve. We're going to go ahead and apply our deadheading pressure with the flush cart pump. We're holding at about almost 50 pounds of pressure, so now it's time to rotate our internal flush valves. Always shut the return off first. Again, you're going to put it into the service position so that the port of the valve is now closed to the flush ports on the heat pump itself. Again, don't forget to rotate both of those into that position and take a moment to verify that it's in that position. We're going to go ahead and shut the pump off and watch our pressure gauge to see if there's any tail off. This would typically also be the time you would burp the pump. Typically a Grundfos pump, you have to burp the ceramic shaft, but these internal variable speed pumps do not require any shaft burping, so there's nothing to do back there on the pump. So at this point in time, as long as there's no tail off on your pressure gauge, which has been again mounted in here between the heat pump and the loop, you're completely purred and you're ready to go into service and do a proper startup. Guys, I can't emphasize enough. Be patient. Go through all the steps to verify you have successfully removed all the air. No one wants to come back and try and explain to the homeowner why they're back doing it again, especially if you kind of rush through this. This doesn't have anything to do with how much time you spent. It has everything to do with verifying you removed all the air from the loop and from your heat exchanger. So again, guys, do it right, do it once, do it well.